Good afternoon. In this video, we will determine the significance of regression model. So in activity 5, we have two problems. The demand for base jumps, shades TV appearance, and the problem 2 is the student of the grade of this student. So the demand for base jumps is the x variable. The green shades TV appearance is the y variable. So to determine the significance of regression model, we have the regression statistics table. In regression statistics table, we have the multiple R, the R square, the adjusted R square, the standard error, and the observations. The value of the multiple R is 0.77020798 The value of the R square is 0.59322039. The value of the adjusted R square is 0.491525424. The value of the standard error is 1.334039361. And lastly, the value of the observations, 6. The value of the observation is 6 because we have the 6 variables in this problem. Next table, we have the ANOVA table. In ANOVA table, we have the regression residual, the degree of freedom, the SSS, the total variation in the variable, the MS, the mean of squared errors, the F, and the significance F. To compute the degree of freedom regression, we have 1, residual is 4. Why it is 4? Because in this problem you have 6 variables, so 6 minus 1 equals 5, then 5 minus 1 is 4. So 4 plus 1 is the total amount of 5. To compute the SS in regression is last activity 5, we have the SSR regression. So this is the value of SSR regression, 10.38135,593. And the last activity 5 again is the value of the SSE. So the value of SSE is 7.118644068. Total amount of 17.5, the scope of the activity 5. So the MS, or the mean squared errors, how to compute the MSR. How to compute the MSR is SSR divided by DF or K, the number of independent variable, which is 1. So 10.38135,593 divided by 1, the equals is 10.38135,593, which is the MSR. To compute the MSE on the residual, formula is SSE. We have the 7.11864406 divided by the residual of degree of freedom is 4. So the MSE is 1.77966117. To compute the F is the MSR and the MSE, the 10.38135,593 divided by 1.77966117. The equal is 5.83333. This is the value of the F, and the significance of F is 0.073139544. So next table, we have the intercept and the demand for base jumps. So coefficients, standard error, the stat, p-value, lower 95, upper 95%, lower 95.0%, the upper of 95.0%. Why it is we have a 95% and 95.0%? So para makuha na to, determine the trial or error to determine the relationship sa x and y para makuha na determine nato So the demand for Bastian, the coefficient is 1.0.59322203339. The standard error is 0.2456165. The t-stat is 2.41522994580. 0.03139544, and so on and so forth. So the F statistic used in hypothesis test is based on the mean squared or error, MSE, and the mean squared regression of MSR. The MSR calculation, as we said earlier, the SSR divided by K, and the F statistic is MSR divided by MSE. Based on the assumption regarding the errors in a regression model, this calculation F statistics is described by the F distribution with degree of freedom numerator and the degree of freedom of denominator. So, I conclude this problem that there is a relationship between X and Y. So we have to next problem is the grade of the student. So next we have the regression statistics table, regression, residual. We have the different degree of freedom, the SSS, the MS, and the F, and the significance F. So the degree of freedom of regression is 9, the residual is 7, the SSS is the SSR, the SSE, then the significance F. So in next table, we have intercept and the first test grade. The coefficient, standard error, t-stat, p-value, lower 95%, upper 95%, lower 95.0%, upper 95.0%. How to compute this variable is same with the formula in the problem 1. Then as we can see in this table, we have in last grade 69, we don't have a coefficient, standard error, t-stat, p-value, lower 95%, and so on and so forth. So I conclude that this problem is there is no relationship between X and Y. That would be all. Thank you.